So in here, we want to explain about how to build our systems. First, we started to make a F100 documents capstone design proposal. In here, we define the problem and choose the best solutions, which is a mobile applications that analyzing traffic patterns to identify strategic location for various sectors. And we also define the development tools for that we will use to develop our mobile applications here. And the next is we continue to make our F200 documents capstone design specifications. So in here we define our main functionality, our user characteristics, our user persona, and so on and so on. And this is our ERD, and we make the ERD or entity relationship diagrams. So in this ERD, we have several entities like record, user, profile, media, media type, and analytics. And for each entity, we have several properties and several properties, and for each entities and each entities have the cardinality between the entities. So and here we also define the data dictionary and the entity tables to help us to make our database schema. And next, we continue to make our F300 documents capstone design project designs. In here, basically, we explain more about our capstone project designs. For the example, in the part C, hierarchical or iterative designs, there are data flow diagrams, implement steps in software engineering design, details of components, references, and library use, modeling by using modeling standard, and in the part D, verification, demonstration, and proof of design process, we provide our application design. For the example here, we have the design for our onboarding page. This is the design of our onboarding page. And the next is the design for our user authentication page. So in authentication page, the login process is simple and secure. So the user just click the continue with the Google button to sign in using the user existing Google account. So user Google credential will be used to securely access our applications. And the next is the design of our home page here. And this is the design for add new record page. Like a camera and the map view page for input the locations. And here the design for the result or detail page. Users can see the analysis result with easy to understand displays, such as the location map views chart to show how many vehicles are detected, and suggestion that can help users to make decisions. And the next is design for record page, or this is the same like the history page. And this is the design for analytic page. Then in this the design for profile page. And after we design our applications, we continuing with develop the front end, our mobile applications. And here is the source codes for our front end applications. In here is a file for make the onboarding page, and this is for the sign up. So for the login, first is use object destructing to extract the login functions, and is login. and isLogin boolean from the useout functions, which later will be used in the doLogin functions. isLogin is then used to check if a user is logged in or not using useEffect that will call the functions every time isLogin value is different. So, and the next is the source codes for make the home page. So in this, every part of the home page, such as vehicle count and the latest record, are nested inside the parent view components in the home page. Here, and building the home page that we've planned in the design, the data for it is fetched using hooks respectively. There is also a refresh control component to update all the data. And the next is the source codes for the record page. The record page is actually like the history page here, and this is the source codes for the analytics page. And in the analytic page, here is started by fetching all the analytics from the user, and then calculates all the data to get the total counts of everything, and provides the data visualizations in a donut chart, and the donut chart also renders its vehicle items in display of car. And the next is the source codes for the profile page. There is a name, email, and the technical logic that are saved in the useStat hook, upload to Cloud Store in the first handler, and the first handler to start the process of uploading the photo profile to the Google Cloud Storage, and after that save the public URL to the user and profile database tables. And this is our main page, or the video main, for one of the main functionalities of our apps, which is to capture or upload video, which will be uploaded into Google Cloud Storage, and the public URL will be saved into our database in their record they belong to respectively. So in this code, there are a couple of main methods or functions that we are going to explain here. So the first one is the start the camera here. This function is used to ask for the device permissions to use the device camera. Then if allowed, start the camera. Next, the start recording. Then the start recording and stop recording function, which as their name describes, start and stop the recording. Next, we have a similar function that we use in the profile page, which is the upload to Cloud Store functions. These functions handles the front end trigger for uploading Google Cloud Storage, while the actual uploading to Google Cloud Storage is handled by the storage service in the .service path. So the next is the record creations file. So in this page, this is the page for user can input the locations informations. It includes a feature for inputting locations with autocomplete suggestions, a map view for visualizing selected locations, and a submit button for saving records. So the input autocomplete components here manage address input, while the main component handles map rendering and user interactions. The component employs functions like move to adjust the map's positions, and on place selected to update the selected locations details. It also utilizes constants for configuring map settings, and a reference map ref to access map related functionalities. So the next is we develop backend for our mobile apps. The next is we develop backend for our mobile apps. So the backend is typically refers to the server-side components and infrastructure for supporting and enabling the functionality of our mobile apps. So first is in the server, I will show you our database schema. We use the data in here. We have a schema.prisma file. This is our database schema, and the next is a user service file. So in user service file here, it defines the asynchronous functions like login user that handles post request. To login a user, it is extract the ID from the request body and checks if it exists. If the ID is missing, it throws an error. Then it uses Prisma to query the database for a user with the given ID, including their profile. If no user is found, it throws an error. If a user is found, it responds with a JSON object containing the user data. If an error occurs at any points, it logs the error, return a 500 response with an error message, and calls the next middleware functions. And the next is the code defines asynchronous functions update user that handles put request to update a user informations. It extracts the email, name, and photo URL from the request body and the user ID from the request parameters. In this code, so for the next is there are record service code. So in this code defines several functions like get all records, get one record, get records analytics, and created record. So in get all record, retrieve multiple records from a database based on certain criteria such as a limit on the number of records and whether they have been analyzed. It turns the record in a JSON response. And get one record, fetch a single record from the database by its ID. If the records exist, it returns it in the response along with information about whether it is currently being analyzed. And in get record analytics functions, it retrieves analytics data associated with a specific record. If the record is still being analyzed, it indicates so in the response. Otherwise, it returns detailed analytics information along the record stats. And the next is the created record functions. It will create a new records in the database based on provided data such as user, associated media, address, and location coordinates, and it turns the created record in the response. And the next is analytics service file. In this file, we have several functions also. Like the get all analytics, get one analytics, and get analytics data, get analytics data, and get all time counts. So in get one analytics functions, it retrieves a specific analytics record based on its ID from the request parameters and sends it as a JSON response. And in create analytics, it creates a new analytics record based on the data received in the request body and sends the created records in a JSON response. And in get analytics data, It retrieves analytics data group monthly from the database, performs calculations on the data, and sends the aggregate monthly analytics as a JSON response. And the last is the get all time counts functions. In here, it retrieves all analytics record associated with a specific user, calculates the total counts for different types of data, for example, car count, bike count, and so on, and send the total counts as a JSON response. So the next steps is we deploy our machine learning models.
Hi everyone, I'm Jessie. Now I'd like to explain about the AI. In this traffic pulse application, we are using Ultralytics. It's a library for YOLO, which stands for You Only Look Once. And it's a neural network for counting the vehicle in frames per frames and track their movements. Then we are using supervision as well for further processing because it's an alternative to OpenCV, such as helping to draw the bounding box coordinates and etc. So the steps in briefly are: first, we retrieve the data from the external API, then the video will download from the storage bucket, then we define the line start, line end, set detection parameters like which vehicles that we want to detect, for example the car, the motorcycle, bus or truck, and we set the annotate frames such as using the supervisions by track, allowing the AI to follow detected object from frames to frames, ensuring when objects are temporarily invisible, or determining the level of confidence until the object is defined as an object. We also create the line zones used to counting the object crossing a defined line. For example, if they cross the line for the first time, it automatically adds the unique tracker ID to vehicles counts. I think that's all how YOLO and supervision works, and we only need to convert all the detections into the tags, such as the durations of video, the type of vehicles, the calculations for the total number of the vehicles, the decisions whether it is classified to middle high, middle low, or industrial area, mixed area, or tourism. For the cloud computing, we are using Google Cloud Platform. We use the Cloud Run to deploy the model AI, OAuth2, Google for authentication user, Cloud Storage for store the model, and SDK Firebase to integrate the cloud storage. And the flow from the mobile apps, it will request the Google Cloud credentials to the OAuth2, and it will request to the Google Cloud, then it will return the ID token to the mobile apps. After the mobile apps get the ID token, it will parse the ID token to the API app server. It also has the Firebase admin to validate. And before we continue, the mobile apps also push the video to the cloud storage, and it will return as a public URL. Then the app server will send the unanalyzed record to the API analyzer server, and it will return the analysis record as a data to mobile apps. And the API is also deployed to the Docker container in Google Cloud Run. And the API app server also will be hosting in Render. So that's all the diagram for the flow for the cloud computing. And for the API, we need these steps. First, we are using Flask as a web framework. We have to specify the endpoint to fetch data from the API and check the status. It returns the response data in JSON format as well, and the URL will be extracted into readable text when it is succeeded. We also set the config to access Firebase storage to interact with the stored files and construct a path to the video file. After that, the AI will process the video, and we have to prepare data for sending the result to the analytics API endpoints. via the HTTP post request with JSON data to attach a record to an analytics ID in application. I think for the cloud computing, that's all. Thank you. So this is how AI works in traffic posts to detect the vehicles or object. First of all, we have to import all the libraries, Firebase, Ultralytics, and etc. And this is the API. It tells the Flask to use the current Python, and we have to extract the file name from the URL by cut the percentage to F in the start index and add the MP4 in the end of the index. And this is the app root for the default home, and this is the app root for receive data using get post method. And I changed the endpoint. This is the this endpoint is from Kennard. So if it is success to get the API URL, so it will return 200 and will return the response in JSON format, and it will get the first record from the response. And if the record data is created, it will return the 200 in status, and if there is no record available, so it will return 404, and if it is failed, so it will return 500. And this app root for predict using get post method as well, it fetch the data from receive data endpoint, and if it is success, it will return 200 and will return in JSON format also. And we have to setting the configurations in so it can connect the Firebase service. That's why we need the Firebase to access the Firebase, so it can interact with the stored files, and then it will download with the name test.mp4. We get the source path, and I check the Ultralytics first whether it is work or not, and if it is work, so I load the YOLO model. And these functions, model.fuse, it is used to normalizations, so it can normalize layers for optimizing the model. And this line used to mapping the class ID to class name. I set the line start, line end, the target video path, and etc. This by tracker, it is used to tracking the system to follow the detected object from frame to frame. And this box annotator used to add bounding box and label to the frame. This trace annotator describes the path followed by the object being tracked and will draw a line that follows their movement. And this line zone is to counting the object crossing a certain line. And this callback, it is used to video processing, where it will return the frame or the video but with the box and line annotated result. So I filters the detections to only consider the class ID from the selected classes before, and implement the by tracker and create the labels for the detected object, including the class ID, the tracker ID, the class name, and confidence level. And I think that's all from the callback. We save the video as well in the target video path. And this is for the timestamp. It will convert a frame index into a timestamp in hour, minutes, seconds format, and it will trigger the line zone to check for the object crossing a predefined line. And this function takes a frame index and frame per second, or FPS, and returns a string representing the timestamp of the frame. It calculates the total seconds by dividing the frames index by the FPS. Then it converts into a human readable timestamp using the time.delta. And this line, last timestamp equal max vehicle counts dot keys. It is to get the latest timestamp from the vehicle counts, and it will extract the counts for the final timestamp. And this is to calculate the total number of vehicle. And I think that's all. Next is about the classify area. It is used to classify the area based on the counts of different vehicle types. It is to describe the likely characteristic or activities within that area. For example, if there is a lot of car, so the majority there is middle to high economic class or stuff like that. And this is only print the final counts with the timestamp. And I type the os.remove because after sending the data, it will remove to help manage resource by cleaning up the temporary files, so the environment is still cleaned. After removing the video files and attaching the record certainly, it returns success to indicate that the process was completed successfully. And this async def send data, it is used to prepare data for sending to analytics API endpoint, and it containing the counts of different vehicles types and the area classifications or decisions. The response analytics used to send the data to the endpoint via an HTTP post request with JSON data. Async def data attach used to send a request to attach a record to an analytic ID. Then we can start the Flash application with if the script is executed directly. I think that's all from the AI side. Thank you.
So right now I will explain about the installation part. So as you can see, I'm mirroring my smartphone here. And then what you can do first is you can click the link that I've sent from the WhatsApp, and then you can just install it right away. But first you need to download it first, so you can just click this install button here. And then what it will do, it will download the application. And then as you can see, it's downloading, but because downloading is quite long, so I will skip this part, and then I will use the installation that I've downloaded before. So in this part, you can just click install, and then it will installing on your smartphone. So yes, it's already done, and then you can just open the app, and yes, our traffic pulse is ready to use. I think that's all for the installation part. Thank you.
Hello everyone, I'm FX Kennard Sugirotok from the Traffic Pulse team. In this video, I'm going to show you the demonstration for our Traffic Pulse app. So here I'm going to demonstrate on my Android phone. So let's get to it. Okay, so when you arrive, you're going to be greeted with the onboarding section here. Welcome to Traffic Pulse. If we go to get started here, if we click get started, and we're gonna go to the login or sign up page, because we have merged the login and sign up function into just one button, because now we think that this practicality and this instant navigation is better for everyone. So let's click continue with Google. Now we have successfully logged into our application. As you can see here, we have arrived in the home section here, or the home page, and you can see a couple of things here. The first one is, you can see the banner here can be used as a place that you can put your, let's say you want to put your advertisement here or something like that. And then the next one we have is the vehicle count. The vehicle count, you can see we have a couple of vehicles that we support now for analyzation. The first one is car, the second one is bike, the next one is truck, and the last one we have is bus. So with the 4 types of vehicles we have here, we believe this is pretty good for making your decision for choosing strategic location for your business or your other needs. The next one we have is the latest records section. So in here you can see that you can look at your 3 latest records that you have put in your account. Let's get to the next page, which is the full records list. You can see here. You can actually get here by clicking the view all here. Okay, the next one, we're gonna skip this for now. The next one we have is the analytics page. Here you can see all the analytics that you have put in your account. You have recorded in your account. So with this, you can see the total vehicles of each type, and you can also see the total vehicles summed up, which is now is 150 in this account. Okay, so now let's get to the next page, which is the profile page. So in this profile page, you can see a couple of things. The first one is the profile picture, and the next one is the information of your yourself. Let's say we want to edit our name or our username. Let's change it to my name, which is Kennard, and then we can just click save, and it will quickly save up your new information. Now, if we want to change our profile picture, we can just click in the profile picture, and I have prepared a photo here of myself, and then let's just click crop here, and then it's going to change my profile to my new profile. So that's all the side features we have for our application. Now let's get to the main features, which is the record functionality. Okay, so we have arrived in the record page, and here is where you want to put your phone on a tripod, and then put it on in front of a building that you want to analyze the street or the traffic with. So, and then you put it there and record there for an hour or two, or you can just upload your own traffic pictures here. Let's say we want to upload this traffic video here. I want to upload this right here. Then I can just click proceed. Then I will go to the location input section. So here you can see we have integrated Google Map, and then you can search for your location. Let's say I want to detect or analyze the traffic in President University, which is in Jababeka. Here you can see we can just click the autocomplete here. So then you can just click submit, and then you will go back to the record list you have. Here you can see on the top we have the newest record that we just put, and also of course you can see it in home also. Now if you want to see the details, you can just click it, and then as you can see the data is still being analyzed. So this will take a while for our system to analyze because because the video can be quite long, and I will just show you one of the records that the system has successfully analyzed. So let's find it. So here I've opened one of the records that the system has successfully analyzed. This is what it is going to look like. So at the top you're gonna have the map visualization with the address written below it. The next one you're gonna have is the same thing that you're gonna see in the analytics page, which is the total vehicle and all of the vehicles percentage here and the count. And the last one you're gonna see is actually our quick analyzation of the result itself of the decision that you have seen. So in the bottom here, we can see that our system can actually analyze and can also analyze if the location or the traffic in the location is mostly middle up economy level or middle below, or maybe tourist, or just mix of traffic. Okay, that's all of the features that we currently have in our application and our system. Thank you for listening to me and thank you for watching this video. I'm FX Kennard Sugirotok from Traffic Pulse team. Have a good day.